How does explosive welding use controlled impact to join metals? Imagine two metals coming together at incredible speeds, almost like a high-stakes collision in a science fiction movie. But in reality, this is a carefully planned process called explosive welding. It uses a precise burst of energy to make two metals stick together without melting them. How does this work? Well, it all starts with a special explosive charge. This charge is placed on a metal sheet known as the flyer or cladding plate. The flyer is positioned at a specific angle and distance above another metal sheet called the base plate. When the explosive detonates, it sends the flyer plate hurtling toward the base plate at extremely high speeds. This impact is not random. It is controlled to happen at just the right angle and velocity. The collision occurs at an oblique or slanted angle, which is key to the process. When the flyer hits the base, the force is so intense that it creates pressures often reaching millions of pounds per square inch. This impact causes a jetting action at the interface, which is like a high-speed flow of metal. This jetting cleans the surfaces by removing oxides and impurities, exposing fresh, pure metal. Because the metals are cleaned at the atomic level, they bond together strongly without melting. This is called a solid-state bond, and it forms a wavy or rippled interface between the two metals. The impact is carefully controlled by several factors. The type and thickness of the metals influence how much explosive energy is needed. The explosive material's detonation velocity must match the metals and impact speed. The angle of impact and the distance between the plates also matter because they affect the quality of the bond and the shape of the interface. Since this process does not involve melting, it avoids problems common in traditional welding, such as warping, grain growth, or brittle intermetallic compounds. This makes explosive welding ideal for joining dissimilar metals like titanium to stainless steel or copper to steel, which are hard to fuse with regular methods. From a failure point of view, explosive welding is designed to prevent impact failure modes like cracking or voids forming at the joint. The high-velocity impact is engineered to cause plastic deformation and jetting that clean and bond the metals without defects. This control over impact parameters ensures the joint is durable and reliable. In industries like aerospace, chemical processing, and power generation, explosive welding is used to create strong, corrosion-resistant, or heat-resistant metal combinations. It allows us to join metals that would otherwise be prone to failure if welded by traditional methods. So, in simple terms, explosive welding uses a carefully controlled high-speed impact to clean, press, and bond metals at a very small scale. This process produces a strong, defect-free joint that resists the common mechanical failures seen in other welding techniques.